Hi GOH, this is Unit 6, Lesson 6, and today we're going to talk about the rhombus. So a rhombus is another special type of parallelogram. It has all the properties of a parallelogram, but it has all equal sides. All right, so a rhombus is a quadrilateral. Whoops, I'm spelling quadrilateral wrong. Sorry about that. Quadrilateral with 4 congruent sides. It is a parallelogram though, so it has all the properties of a parallelogram, plus it has some extra properties which we're going to discover. All right, so we can prove it's a parallelogram by using the definition of a rhombus. Given that ABCD is a rhombus with diagonal BD drawn, why must the triangles be congruent to each other? Well, I know it's a rhombus, so that makes these sides all congruent. So AB is congruent to BC, is congruent to CD, is congruent to AD. All sides are congruent. It's a rhombus. They also share side BD in the middle. So BD is congruent to BD, reflexive. This is sort of an informal proof. And they wanted us to show why is triangle ABD congruent to triangle CDB? Well, we can see by what I have marked, side, side, side. Now that I know the triangles are congruent by side, 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 why is angle 1 congruent to angle 2? Well, the triangles are congruent, so therefore angle 1 is congruent to angle 2 by CPCTC. And based on that, what can you now say is true about AB and DC? So AB and DC are the top and the bottom. Oops. So they are parallel to each other. So AB is going to be parallel to DC because angle 1 and angle 2 are alternate interior angles. Angle 1 is congruent to angle 2, and they were alternate interior angles. Therefore, those sides have to be parallel to each other. And they were alternate interior angles. So, therefore, ABCD is a parallelogram since one pair of opposite sides, and meaning top and the bottom in this case, one pair of opposite sides are both congruent and parallel. I know they're congruent back from the beginning when I said they were all congruent, and I know they're parallel because those alternate interior angles were congruent to each other. All right, so I was just confirming that that rhombus is in fact a parallelogram. All right, but rhombuses have a lot of extra properties. In addition to all the properties of a parallelogram, they have some extra ones which we are going to discover right here. So I'm going to measure RS, ST, TU, RU, RW, and RT. All right, so I know this is a rhombus, and I have diagonals RT and SU. So I measured this. This was 5.3. This was 5.3. All sides are congruent, so they all have to be 5.3. This was 5.3. I also measured this. RW is 2.2, and this was 2.2. And I think that's all they had me measure. Which triangles below are congruent to RWS? Basically, all the sides are congruent. This side was congruent to this side. This diagonal is congruent to this one, and all those sides are equal to each other. So basically, all the triangles are congruent to each other, right? Because they are congruent by side, side, side. There are 4 congruent triangles created by the diagonals of a rhombus. That is not true in a parallelogram or a rectangle. They are 4 congruent triangles. All right, so interesting. That's going to help us out with some of these properties right here. So the diagonals of a rhombus divide the rhombus into 4 congruent triangles. These triangles lead to more interesting properties of the rhombus. First, let's prove that they actually are congruent. All right, so this is going to be a proof. We'll do it together. We'll do it fast. Basically, you know that RSTU is a rhombus. That's the given. If it's a rhombus, then I know that RS is congruent to RU. RS, where's RS? RS is congruent to RU, because that's the definition of a rhombus. And I know that RW is congruent to RW. That's that one right there. And that is because of reflexive. And I know that RT bisects US. Remember, the diagonals bisect each other. So if RT bisects US, and that reason is a rhombus is a parallelogram, and diagonals of parallelogram bisect each other. So I now know that this is congruent to this. So I know that UW is congruent to WS. And that is definition of bisector. So basically, now I can say that this triangle on the left is congruent to this triangle on the right. Triangle RWS is congruent to triangle RWU by side, side, side. All right, so I did it. Now, here are some properties that are going to come up because of that. So there are 2 additional properties of rhombi, that's the plural of rhombus, that you can deduce from those 4 congruent triangles. Given the diagram above and proven the fact that the 4 triangles are congruent, what can you say about the diagonals being perpendicular to each other? Well, the 4 angles created by the diagonals must be equal. Okay, so this angle right here, angle W, well, we can't really say angle W, but let's call them 1 and 2. If I were to call those angle 1 and angle 2, they have to be congruent. The triangles were congruent, therefore those are corresponding parts of congruent triangles. Those have to be congruent as well, and they form a line. Therefore, they have to be equal to 180, and if they're congruent and they're equal to 180, now I know that they are perpendicular to each other. Okay, so let's say that angle 1 and angle 2 are congruent by CPCTC, and they form a linear pair. So they must be 90 degrees, so they are right angles, and therefore the diagonals are perpendicular. So that's the big thing that I wanted you to get out of this, is that the diagonals are perpendicular. The other thing is, let me call this angle 3 and angle 4 up here. Those have to be congruent also by CPCTC. Therefore, the second big thing is that the diagonals bisect the angles. All right, the diagonals bisect the angles. So 2 important facts from rhombuses is that the diagonals are perpendicular, and also the diagonals bisect the angles. All right, so question 5. I have a rhombus. The diagonals are 10 and 24. All right, so let me draw the diagonals in. Now they bisect each other, so that makes this 5 and 5, and this makes this 12 and 12. But we also just said the diagonals were perpendicular, so therefore this is just a right triangle, and I can use the Pythagorean theorem to find the missing side of that rhombus now. So 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. Well, 25 and 144 are 169, so x equals 13. All the sides are congruent, so all the sides are 13. And the perimeter is just 13 plus 13 plus 13 plus 13. Or 13 times 4. The perimeter is 52. Okay? And last one, given that ABCD is a rhombus and angle CBD is 67, then which of the following is a measure of angle BAD? So BAD is down here. Well, if it's a rhombus, the diagonal bisects the angle, so this angle on this side is also 67. All right? And all the sides are congruent to each other, so that makes this 67. Right, because that's really just an isosceles triangle. This right here is an isosceles triangle. That makes angle C 44. 67 and 67 is 134, and 180 minus 134 is 46. And if angle C is 46, then angle A is 46. All right, so we'll practice with those properties of rhombuses tomorrow.